Hi, I'm Dr. Faisal again. Now, I'm going to explain to you about our experiment number 3, which is determination of zinc by linear calibration and standard addition methods using atomic absorption spectroscopy. The machine besides me. Atomic absorption spectroscopy is a technique for determining the concentration of metal element or minerals in the sample. The technique can be used to analyze the concentration of over 70 different metals in a solution. It uses absorption or emission spectrometry to assess the concentration of analytes in samples. Electrons of atoms in the atomizer are promoted to higher orbital for a short amount of time by absorbing a quantity of energy of at a given wavelength. This amount of energy or wavelength is specific to a particular electron transition in a particular element. This gives the technique its elemental selectivity. Quantitative analysis require accurate and reliable measurements that relate to the composition of the sample. In instrumental techniques, the proportionalities need to be practically established in the calibration procedures. In a typical simple calibration, a range of standards is prepared containing varying amount of the analyte. So now we are going to use this technique to determine zinc in our sample using AAS. The first step of this experiment is the preparation of the stock solution. We require 1000 ppm of zinc. This can be done by measuring 0.44 grams of zinc sulfate to the nearest 0.1 milligram or decimal places. This is what I'm doing now. I'm transferring the standard into the beaker and weighing. Now I get the amount that I require, 0.44 grams. The next step in this process is to prepare the solution. I am going to dissolve the 0.44 grams zinc sulfate in 100 milliliter of deionized water for dissolving the salt in the ionized water. Stir it, right, to make sure that it is homogeneous, right? And then the next step, of course, after preparing this, I have to transfer into 100 milliliter volumetric flask. Right. So now let us prepare this first. Okay, we stir. Right. Then get our volumetric flask. Then you can start transferring the solution into 100 milliliter volumetric flask. This is how it is going to be done. Then we add distilled water, the ionized distilled water, into the volumetric flask up to the mark. We have to be very careful. We have to make sure that we have high level observation. Now, okay, since it's coming to the mark, I have to stop it. I have to make sure that I am at the level. Right. Now I'm transferring small amount using dropper, small amount of deionized water using the dropper to make sure that the meniscus attains the mark that I want. Now, it's about it. I think we got it. Just a little bit, one more drop to go. Yeah, that's it. Fantastic. Now, put up the cap and make sure that you mix the solution by flipping this up and down for several times to make sure the homogeneity of the solution is prepared. Now you have the 1000 stock solution. Since we have done preparing the stock solution of 1000 ppm zinc, the next step is to prepare the working solution. We need to prepare 10 ppm of working solution from the stock solution that we have prepared earlier. Now I'm going to show you how that can be done. So I am going to pipette.
Okay, now I will stop for the first 5 minutes of this video. and I will ask several questions. Okay. Ahmad Hassan.
Yes, doctor.
Okay. What are the equipment that is going to be used in this experiment to determine the concentration of zinc in a solution?
Firstly, we'll use 100 milliliter of volumetric flask
No.
and the dropper.
Okay. No. I mean the name of the equipment, Hassan.
Oh, the name of
Yeah.
equipment.
Yeah.
Mm,
The equipment that will be that is going to be used in this experiment to determine the zinc in the solution. The name of the equipment.
oh, AAS
AAS stands for.
stand for atomic absorption spectroscopy.
Okay, thank you very much, Hassan.
Okay. Good.
Okay. Um, Chan Wei Chow. Chan Wei Chow, are you here? Hello, Chan Wei Chow. Okay, I mark that as not answering. I will come back to Chan Wei Chow after this. Edward Kwek Junji.
Morning, doctor.
Good morning. Okay, according to Dr. Faizwan just now, he mentioned that there are how many elements can be detected by using this AAS? According, from the
Mistaken, I think
video,
it's 70 plus.
70, yeah, 70 elements that can be determined by using the AAS equipment. Thank you, Edward. Okay. Muhammad Afif Azhar. Okay, Muhammad Afif. This detection using this AAS is a type of quantitative or qualitative analysis. Quantitative. You think? Are you confident? Okay, thank you. Okay, good. Ada kawan tolong kat belakang tu eh. Okay, Felix Salim.
Yes, doctor. Good morning.
Good morning. Okay, can you describe further what is the difference between qualitative analysis and quantitative analysis?
When it comes to quantity, we measure the quantity of a particular substance in the sample. When it comes to the quality, it is the quality of the sample. Like we would like to analyze what's in the particular sample.
Can you give example of qualitative analysis? Simple example. Okay, it's okay. You have answered the first question. Thank you, Felix. Okay. Kavinesh. Kavinesh.
Yes, doctor.
Okay, Kavinesh. Can you name the name of salt being used in the experiment in the video in the video just now? The name of the type of salt being used by Dr. Faizwan just now. Or can you name the chemical formula? The its chemical formula? Hello, Kavinesh. Okay. Sorry? Zinc what?
Zin, can I tell the chemical formula right, doctor? ZnSO4 4 dot 7:0.
Okay.
Zinc sulfate.
Okay. Okay. Thank you, Kavinash. Very good. Okay. Puteri Aisyah. Puteri Aisyah A. Rahman Ansari.
Yes, doctor.
Okay. Puteri, just now Dr. Faizwan has prepared a stock solution for the zinc sulfate. Okay. What is the concentration of the stock solution prepared? Hello?
100 ml.
ml. 100 ml is not correct. The concentration, 100 ml
One.
is the volume, the concentration. Okay, it's okay. I ask your friend to help. Siti Norliza, can you help Putri on how many uh um what is the concentration of the stock solution prepared just now by Dr. Faizwan? Siti Norliza, are you here?
Yes, doctor.
Okay. The concentration of the stock solution been prepared just now?
One 1,000
1,000. The unit?
mol.
No.
Um,
The unit for the concentration.
ppm.
ppm. Okay, thank you.
Okay.
Thank you, Noliza. Okay, Siti Zakia. Siti Zakia.
Yes, doctor.
Okay, ppm stands for?
Concentration.
Yes, it is a concentration, but ppm stands for
Part per million.
parts per million. Thank you. Okay. My last question goes to Nurina Batrisha.
Yes, doctor.
Okay. Later on, we will Dr. Faizwan will prepare a working solution of how many ppm. Before I stop the video, Dr. Faizwan is now preparing for the working solution. Just now, initially, he prepared for the stock solution. Later on, he will prepare a working solution of how many ppm? 10 ppm. Okay, thank you. Okay, now I will resume back the video.
Amount from this standard stock solution that I prepared earlier
Maybe I will go back.
of 1000 ppm zinc, the next step is to prepare the working solution. We need to prepare 10 ppm of working solution from the stock solution that we have prepared earlier. Now I'm going to show you how that can be done. So I am going to pipette certain amount from this standard stock solution that I prepared earlier. Right? I'm going to pipette that out. Okay. And I would like to transfer that amount of stock solution that I have prepared. Okay, let us get the volume into the next volumetric class. Right? Well, you have to calculate that. I'm not going to tell you the amount. M1V1, M2V2, guys. Right, so since I have already transferred certain amount of the stock solution into the next volumetric class, now I'm going to fill up the volumetric class with distilled water. Right up to the mark, the same process that I demonstrated earlier. Right, so upon attaining to the mark, I should be able to get my 10 ppm working solution of zinc. Right, just pipette a little bit more to make sure that we get to the mark. Okay, a little bit more, maybe a little bit more. Right. I think a few more drops maybe. Okay. Okay, a little bit more. Little bit more. Carefully. Be sure that you get the meniscus right to the mark. Okay, I think I got it. Now, I have to cap this volumetric mass, and the same process I have to flip upside down several times to make sure that the solution is homogeneous. Now I have the working solution of 10 ppm. Next, I'm going to prepare the calibration standards, right? So I'm going to need 5 different volumetric class because I have to prepare 5 different concentrations of calibrators at 0.5 ppm, 0.4 ppm, 0.3, 0.2, and 0.1 ppm. Right. So to prepare this, I have to prepare using serial dilution. I'm going to take certain amount from the stock solution and transfer into the first volumetric class to prepare the 0.5 ppm and then transfer certain amount from the first volumetric class to the second volumetric class to prepare 0.4 ppm and then to the next, right? So using the serial dilution process. At the end of the day, I'm going to have 0.5 until 0.1 ppm. So these are the calibrators that I'm going to use to prepare my calibration curve for determination of the zinc. The next step is I'm going to prepare the standards and sample for standard addition method. I'm going to transfer 20 milliliter from this sample into every single volumetric mass here. And then I'm going to make up the concentration to X plus 1 ppm, X plus 0.75 ppm, X plus 0.5 ppm, X plus 0.25 ppm, and X plus 0.0 ppm by adding certain amounts of volume from the working standards that I prepared earlier. The volume will be made up to the mark using distilled water, and you have to be very careful when you are doing that. Make sure that you get the meniscus right on the dot. Now, I think we are ready to perform our AAS analysis. Come, let's go. We go to the AAS machine and do the analysis. Come, follow me. Assalamualaikum dan salam sejahtera. Nama saya Zaini.
Okay, I will stop before we listen to the explanation on the AAS. Okay, Amalia Azhari.
Yes, doctor.
Okay, when you are diluting your sample in the flask, either you're in a shake flask or in a volumetric flask, what is the important criteria for you to look at to ensure that you have the correct volume? How do you ensure that you obtain the correct volume?
By saying whether it is on the mark or not.
Okay, so the correct way to do it is to make your eye level in the same level as the mark, isn't it? Okay,
Yes.
thank you, Amalia.
Okay, thank you, doctor.
Okay, okay, Dr. Faizwan just now mentioned that to determine the concentration of the zinc in the solution, first of all, we need to prepare the standards, isn't it? To prepare the standards. So, how many standards does Dr. Faizwan prepare just now? Krista Parenti, how many standards that Dr. Faizwan used just now? Krista, are you here? Krista. Okay, Krista. Okay. How many standards? Sorry? Five standards. Okay, thank you, Krista. Muhammad Ahmad. Muhammad Al-Batati.
Yes, doctor.
Okay. Can you mention the constitution of the standards being prepared by Dr. Faizwan? There are 5 standards. There are 5 standards with different
0.1,
constitution. 0.0
0.2, 0.3, 0.4, 0.5 ppm.
ppm. Okay, thank you. Very good. Okay. And then Muhammad Faisal, are you here?
Yes, doctor.
Okay, Muhammad Faisal. The standards, the 5 standards prepared by Dr. Faizwan is by using a type of dilution from the stock solution prepared earlier. What is the name of the dilution?
Deionized water.
No. The name of the dilution being done using the stock solution, it is named as serial dilution. Okay, serial dilution supposedly the answer. Okay,
Using using distilled water as blank.
yes, using
something.
distilled water. Yes, need to be diluted with distilled water.
Yeah.
Okay, Muhammad Shafiq. Muhammad
Yes,
Shafiq. Okay. How can you mention the formula for the dilution? The formula that you will be using for the dilution from the stock when you have a higher concentration from your stock solution and you want to prepare uh, another type of concentration which is much more diluted than the stock solution. So what is the common formula that is normally being used to calculate for the how many volume that you need to take from the stock into the second flask to prepare the more diluted concentration. Dr. Izwan has mentioned just now in the video the formula.
M1 V1 equals to M2 V2.
Yes, very good. Thank you. Okay, so you will be using the M1 V1 equals to M2 V2 formula to calculate for the dilution, the concentration of the diluted sample. Okay. Okay, now I think we can resume the video. But this video is in Bahasa Malaysia, I think. It has been recorded in Bahasa Malaysia. So for those international students, maybe you can ask your friends to help you to translate what does this technician describe on the AAS system. Okay, now he will be explaining how to operate the AAS machine. Okay.
Saya telah bekerja di PM ini selama 30 lebih tahun dan apa yang saya nak katakan di sini sebelum anda prepare bahan-bahan anda perlulah menjaga SOP preparation safe procedure di mana kamu kena guna PPE, kena guna goggles, mask dan glove ya. Dan apabila datang sini di sini ada SOP penggunaan alat untuk menjaga jangka hayat alat ini ya. Dan alat ini namanya Emma model AAS 400. Daripada Emma Analysis 400. Okay. Dan sebelum anda on-kan semua, anda kena jaga SOP anda ini, di mana bukakan gas, H2H2, di mana acetylene digunakan, gas acetylene, dan on-kan device, instrumen ini, dan PC, on-kan ini, ini, dan PC, dan selepas itu kita on-kan compressor di luar, iaitu oksigen yang akan membantu pembakaran. Dan sebaliknya bila nak tutup, kita off-kan sana compressor, device dan isi dan barulah device dan gas. Dan sebelum untuk menganalisis, kita gunakan input ini sebab kita berada di dalam keadaan yang boleh kata bahaya di mana kita menggunakan logam-logam berat. Dan di sini saya terangkan bagaimana fungsi alat ini. Alat ini berfungsi untuk menentukan sesuatu pekatan logam yang kita tidak tahu, tapi kita tahu logam sebenar. Katakan kita nak cari zinc, kita dah tahu zinc, dan tapi kita tak tahu kepekatan dia sebenar. Dalam di sini menggunakan unit ppm. Dan di sini saya terangkan stand alat-alat ni. Ini dipanggil nozzle. Dan keseluruhan ni dipanggil chamber. Nozzle ini ada satu berbola bil dan depan berbola bil ada spoiler. Di mana bila dia menyedot, dia akan mengatomize seperti kamu gunakan perfume atau paint atau spray seltop. Bentuknya begitu. Dia akan mengeluarkan satu percikan yang sangat halus dan small. Dan apabila dia sedut di dalam chamber ini, dan atom-atom tadi akan teruja, dia akan chopping daripada dalam ni. Dia akan teruja atau atom terhasil dan terbebas di atas ini. Dia akan putuskan rangkaian atom dan atom tadi akan terhasil di atas. Dan kita gunakan source. Kita nak cari zinc, kita gunakan lamp zinc. Sebaliknya kalau kita nak gunakan, kita nak cari cadmium, kita gunakan lamp cadmium. Ini dipanggil mono cathode lamp. Di mana dalam dia ada anode dan cathode cadmium lah. Kalau kita guna zinc, zinc lah. Mono cathode lamp. Di dalam ini ada 4 housing, tapi kita boleh gunakan satu dalam satu masa. Dia tidak seperti ICPMS, dia boleh gunakan satu saja. Okay? Dan bila atom-atom tadi telah terjun di atas benda ni, dia panggil gas benar. Di mana kita gunakan lamp cadmium. Cadmium tadi akan menyerap cadmium saja. Kalau yang terbebas itu, cadmium, plumber atau sebagainya, dia sebab kita nak cari zinc, dia akan serap zinc saja. Bila dia nak absorb, dia akan hantar ke detector di sini dan terus dia hantar menjadi spektrum. Dan data-data ini akan ada olah balik jadi membuat laporan dengan kepekatan yang sebenar, di mana anda akan mencari Y and X campur C, keceronan yang sebenar yang akan anda lakukan. Buat laporan ya. Dan sini tak ada apa.
Okay. So I stop again the video. Okay. Just now the lab technician describe on how to operate the AAS machine. Okay. So Zarfan.
Yes, Doctor.
Okay, Amir Zafan. Can you name the type, the brand, the type of brand for the AAS equipment that is available in the lab just now? Amir? Can you remember the type of brand of the AAS available in the lab just now? Cannot remember.
AAS.
AAS is the type of equipment, the brand of the equipment.
Cakap.
Uh-uh.
Nioba.
Nioba, Perkin Elmer. Okay, it is Perkin Elmer is the manufacturer lah. Normally the high end machine normally being used in the R&D unit or in the lab is normally being supplied by Perkin Elmer. Perkin Elmer ni is one of the biggest supplier for R&D machine. Not only ES, they also supply several other more equipment yang which is high end punya. Alright, thank you. It is Perkin Elmer. Okay, thank you Amir. Alitia Handralita Agus.
Yes, doctor.
Okay, Alitia. Okay, before we operate the AAS machine, okay, because it involve the s- the sparkle of tiny particles, okay, which can be inhaled, and it is we can say that it is hazardous. Okay, so we need to wear suitable PPE. Okay, can you name one PPE before you operate the AAS machine? Only one. Hello, Alitia.
Dozer,
Sorry?
face shield.
Face shield.
Yeah.
Face shield. Okay, good. Face shield, one. Okay, Chong Yong Cheng. And other PPE needed?
Glove.
Glove, okay. Face shield done. Glove done. Lai Wan Jing. Other PPE?
Mask.
Mask, okay. Face shield and mask, okay, good. Okay, maybe last one. Lo Kit Hong.
Lab coat.
Lab coat, yeah, of course, lab coat. Okay, thank you. Okay, now we go to Nabila Wahyu.
Yes, doctor.
Okay. So just now the lab technician mentioned about the while operating the AS, it needs to be done in a fume hood. Okay. So why does it need to be operated in a fume hood? Hmm. Okay, maybe I can ask your other colleagues to help you. Nur Husna Akila, can you help Nabila Wahyu? Why do we need to on the fume hood while operating the AAS machine?
Doctor, I think to prevent the of hazardous substance.
Okay, to prevent the hazardous substance from. Very good. Okay, from not yet completed. Your sentence is not yet completed. From.
From
Okay, continue. From. Your initial statement is correct. To prevent hazardous substance. Okay. From.
zinc.
From, sorry. From entering. I give you hint.
Being
Entering the hazardous fine particle. We want to prevent it from entering
water.
water. No,
Oh no,
it is actually.
so air, free air.
Sorry.
to prevent entering the air.
Yeah, okay. Can be accepted to prevent from entering the air and eventually to prevent from entering our nose and our lungs so on. Okay, it is especially to secure our health lah, human health, who is operating the machine. Yes. Okay, thank you, Nabila. Okay, then I go upon Wong Chi Tim. Hello, Wong Chi Tim.
Doctor.
Okay, Wong. Um, there are the AS machine. There are several compartment. Okay, that has been combined together, to operate the AS machine. Okay, one of them is nozzle. Okay, what is the function of nozzle? That small tube. Or maybe I can change atomizer. What is the function of atomizer? Hello, Wong. Okay, maybe I can ask your other colleagues to help you. Surin Nash. Surin.
Yes, doctor. The nozzle, right?
Can you help Wong? Either the function of the nozzle or the function of the atomizer.
Okay. The function of the nozzle is to draw in the solution into the AAS.
Yes, thank you very much. Surin. Very good. Okay. Wong Chitim. What about atomizer, Wong?
It's here to produce the
Okay, produce.
fine spray.
Yes, fine spray, fine particle, isn't it? Just like the one that been used. For example, the analogy is in our perfume or in the aerosol where when we press it, there is it becomes very fine particle. Okay, that is in this system we call it as atomizer to produce fine particle. Okay, thank you, Wang. Okay, Sarwin. Am I pronouncing your name correctly? Sarwin.
Yes, doctor.
Okay. Uh, Sarwin, isn't it? Or Sarwin? Sarwin?
Sharwin.
Sarwin. Okay,
Yeah.
Sarwin. Can we use a sample in solid form for this AAS?
I think can, doctor.
You think can?
Yeah.
Okay. Sidesh, can you confirm the answer given by Sarwin? He mentioned that a solid sample can also be used for this AS to determine, for example, to determine the concentration of zinc in the solid sample. Can it be done? Dash.
I think yes.
You think yes? Okay. Can I confirm again with the third one? Pu Chuan Shin. Chuan Shin. Pu Chuan Shin.
Doctor, I think cannot.
Cannot. Yes, the answer is cannot. The answer is cannot, Sarwin and Sidesh, to determine any compound, heavy metals inside the sample, by using this AS, it must be in liquid. As mentioned by the lab technician just now, you must, if your sample is in solid, you must convert it into liquid form first, because the AS machine only can suck the liquid form. Okay, thank you, Po Chuan Shin, for the correct answer. Okay, so last one, Ong So Yi.
Yes, doctor.
Okay, just now the lab assistant mentioned about the one that is being used to determine the compound. For example, if we use zinc, or for example, if we want to determine zinc, or we want to determine any other heavy metal such as cadmium, for example, what are the important parts in the being put in the AAS system? What is the name? The name of the most important part.
Um,
Mm.
and not
Cathode. It is supposed cathode.
cathode and anode.
Okay. Yes, the cathode and anode is inside that thing. What is the name of that part? Hollow cathode lamp, isn't it? Okay. So it should be the name of that part being put inside the is named hollow cathode lamp. For zinc or for cadmium, it is specified for a certain compound. Okay, if you want to determine any other compound, so you need to change that lamp. Okay, thank you, Ong So Yi. Okay, so we have a few more for this video.
Dan sekarang kita gunakan teknik flame. Di mana dia menggunakan api. Ini dipanggil teknik flame. Kita ada 3 teknik. Hydrogen dan juga graphite. Di mana jika anda tidak mendapat hasilnya dalam kepekatan ppm, anda boleh cari, bukan bermakna anda tidak dapat, tapi anda boleh cari dalam kepekatan yang lebih rendah. PPB yang bukan hydrogen dan graphite. Sinilah dia akan edit. Semua sampel-sampel ada apa standard semuanya dalam bentuk larutan, bukan pekerjaan. Dia akan edit di mana yang saya terangkan tadi, dia akan optimize dan atom-atom tadi berhasil untuk bebas dan kemudian di atas akan diserap oleh lens zinc. So, dia akan letak di sini sebagai spectrum dan data-data anda akan olahkan semula di dalam Excel baru dapat kepekatan dia yang sebenar. Okay, terima kasih. Okay, ini adalah seperti mana setiap pengoperasi alat ini akan membuat satu kalibrasi yang sebenar. Kepekatan 0.3 ppm akan mengeluarkan bacaan setidak-tidaknya 0.18, dan sebenarnya 0.2. 18 dah memadai. So,
Okay. So basically, we've done with the video presentation for this experiment 3 in determining the concentration of compound. In this video, we use zinc to determine zinc in a solution. Okay. Okay. Nurul Khairiyah Aziati.
Yes, doctor.
Okay. just now the lab assistant mentioned about a technique being used in the AS. What is the name of the technique?
Flame.
Flame technique. Okay. Thank you. Okay. Nurul Shahira.
Yes, doctor.
Okay, Nurul Shahira. Okay, besides ppm, let's say if we have a much more smaller concentration, smaller than the ppm, what is the name of the concentration that also can be used? Mm,
PPB.
PPP. Okay, thank you very much. Nurul Fatin Hazika. Nurul Fatin. Are you here, Nurul Fatin? Okay. Hello, Nurul Fatin. Good morning.
Yeah.
Okay, Nurul Fatin.
Yeah.
What is PPP? PPB stands for
Part per billion.
parts per billion. Okay, thank you. Okay. Okay, I've done. Okay, maybe I can just call upon name again. Chan Wei Chow. Are you here, Chan Wei
Yes,
Chow?
doctor. Yes,
Okay.
I'm here.
Okay, just now, where have you been just now? I did call. I did. Oh,
Actually, my alarm didn't go off, so I was late.
sorry. Actually, your what?
My alarm didn't go off, so I was late.
Your alarm. Oh, okay.
Yeah.
All right. Nur Husna Akila, are you here?
Doctor.
Okay. Nur Adlin.
Yes, doctor.
Okay. Rodiatul Ahya.
Yes, doctor.
Okay. Okay, I think we've done for today. For today lab. Okay. So again, Supaklit, please submit your logbook as soon as possible. Okay. So before we end our lab session, do you have any question to ask regarding this experiment 3?
Doctor, so for the result later, doctor will upload in the e-learning, is it?
Okay.
The result for the mean absorption for each sample.
Okay, maybe I can ask Dr. Shazwani, Dr. Amy. Dr. Amy, what
Hi. Yes.
about the result?
Okay. Okay. I think we have the pre-recorded data from the AAS. We will upload it inside the e-learning. Let me check first, yeah. Okay. By the way, Dr. Izian, just
Okay.
now, who's the student that is late? Is it Chong Wei Chow?
Chan Wei Chow.
Chong Wei Chow.
Yeah, yes, me,
Are you
doctor.
are you late for the whole session?
No, 30 minutes.
30 minutes. Wow.
Yes.
30 minutes and we are actually 1 hour only session. Because of that, you have to understand that we have to deduct the mark for lecture observation, okay?
Okay.
How about your logbook? Is your logbook already uploaded?
Yeah, yesterday already uploaded.
Okay.
Only Supaklit haven't uploaded his logbook.
Okay, let me check. Okay, anything about the pre-recorded data, I will mention about it in the WhatsApp group, but I believe it's already there somewhere in the Google Drive. I think that's all from me for the data, Dr. Izian.
Okay. Okay, thank you, Dr. Amy. Any other question?
Okay.
No question. Okay. Okay. Maybe I can pass to Dr. Amy.
Okay, for the graph, you have to do using Excel. Okay, you can use directly from Excel, and you can also try if you want to draw it manually also can, but the y mx plus c and r square needed to be obtained from the Excel anyway. So yeah, you can take directly from Excel.
It is much more easier maybe to
Yes.
use Excel to plot the graph.
Yes. Yes, it's easier.
Yeah.
However, if let's say you want to draw, also recommended, because if let's say this kind of question asked in a final exam or test, you have the experience already. That's only my recommendation for students.
Okay. Okay.
Okay.
Any question? Any other question? 1, 2, 3. Okay, if no question, okay, thank you very much. Please do your lab report together with your partner. Okay. If there is any problem with your partner, don't hesitate to inform either me or Dr. Amy, okay, personally. Okay, thank you very much to all. Till we meet again. Okay, Assalamualaikum and bye-bye.
Thank you, Doctor.
Thank you.